Hey everyone, welcome back to The Explainer, brought to you as always by Forge College. Okay, let's jump right into it. Today's lesson is consolidating testing strategies into a basic foundry workflow. We're shifting gears, moving away from pure theory and getting our hands dirty with something absolutely crucial for your day-to-day as a dev. First off, seriously, huge congratulations. If you were here, it means you survived the incredibly dense synthesis, Gulf Stream theory, and forwarding implications from our last lesson. You made it. But, okay, now we face that deeply relatable developer pain. How do we actually test our smart contracts without completely losing our minds? Look, we've all been there, right? Typing random test commands into the terminal, crossing our fingers, maybe praying to the code gods a little bit, and totally ignoring that giant wall of angry yellow warnings. Well, today, we fix that. Okay, let's dive into this. Here is our agenda for today to fix that messy workbench. We're going 1. From chaos to pipeline. 2. The 3 levers. 3. The assembly line phases. 4. Building the script. And finally 5. Capturing artifacts. Let's get to it. Section 1. From chaos to pipeline. The engineering blueprint. So right now, your testing process probably feels, well, kind of like an ad hoc scramble. What we desperately need is a predictable mapping from our test intent, meaning what we actually want to verify, to how we invoke those tests. We really need to stop treating software testing like this chaotic, cluttered desk where we're just poking at code randomly. Instead, think of it like a precise physical factory assembly line. Literally everything needs a dedicated place, a crystal clear purpose, and a very specific order of operations. All right, moving right along to Section 2, the 3 levers, controlling the workflow. To control this brand new testing machine we're sketching out, we've got 3 distinct levers we can pull. First up, test layout and naming conventions. Where you physically place your files and what you actually name them, yeah, that matters deeply. Second, forge flags and environment variables. These dictate exactly how things run under the hood, like say path matching or setting a fork URL. And third, wrapper scripts. These basically encode your specific testing policies so the whole thing runs the exact same way every single time. And by the way, adopting a highly structured approach using these exact levers, that's a huge focus in the programs over at Forge College. It's kind of what separates the weekend hobbyists from the true engineers. Which brings us to Section 3, the assembly line phases, grouping and execution. Okay, so we're going to break our tests down into 3 very distinct, manageable phases on this conveyor belt of ours. First up, the unit group. These are your lightning-fast checks with deterministic assertions, and you run these on every single local change. Next, integration. These are much broader. They handle external state, usually grabbing a fork URL, and you'd run these manually or let your CI pipeline handle them. And finally, verify. This is your heavy-duty pre-merge pipeline audit. It spits out gas reports, deep traces, the whole shebang just to ensure absolutely everything is rock solid before you ship. Now, to actually make this work physically in your code, we organize the directory tree with totally separate folders. You've got one for unit tests, one for integration tests, and one for your output artifacts. Why do we do this? Well, pointing your tools to these specific folders ensures that your lightning-fast unit tests never, ever accidentally get bogged down because they somehow depended on a fork URL or some messy external network state. Keep them separated. Doing that keeps your workflow completely predictable. Next up, Section 4, building the script. The engine. This is where the magic happens. We are going to compose a repeatable bash script that acts as the engine, executing our steps in strict sequence. Step 1, unit tests. Fast, silent. And hey, if they fail, the whole conveyor belt stops immediately. No point in going further. Step 2, integration tests. These run against a forked mainnet to verify all those tricky external interactions. Step 3, verification. This gathers up all your JSON outputs and traces. Setting your engine up this way guarantees that your fast feedback loop happens first. It literally saves you from sitting around waiting on heavy integration tasks if just a basic unit test is already broken. Now, what's really interesting about this slide is this one simple little line of bash code. See it? It generates a unique run ID based on the timestamp and the phase. This is such an elegant way to ensure that artifacts from different test runs are completely isolated from each other. It entirely avoids cross-contamination. That means every single time you execute a test, it gets its own pristine, perfectly reproducible workspace. It's a real game changer. And that brings us to Section 5, capturing artifacts, the quality assurance log. Okay, let's take a second and demystify this term artifacts. I know if you're a beginner, it probably sounds like we're going on some kind of archaeological dig. But in our context, artifacts are just saved logs, ABIs, JSON traces, and terminal outputs, all captured nicely in a dedicated folder. Honestly, just think of an artifact as a highly detailed, printed receipt of exactly what happened during your test. Having that receipt makes it infinitely easier to diagnose exactly why something might have failed. So, why do we care so much about hoarding all these receipts? Because of the ultimate developer superpower they unlock. By grabbing a Run ID artifact bundle and using identical environment variables, you can flawlessly, and I mean flawlessly, reproduce a complicated remote continuous integration failure right there on your local machine. No way, right? Yes way. No more guessing what went wrong in the cloud. You can recreate the exact conditions right in front of you. So the absolutely crucial point here is that this deterministic workflow scales incredibly well when you're on a team. It totally eliminates that dreaded, well, actually it works on my machine excuse we all hate. You share the structured layout, you share the execution script, and you share the verifiable truth of the artifacts. Tests stop being these random commands typed by one person in a basement and become shareable, debuggable procedures. With this rock-solid foundation finally built, next up in our advanced testing with Foundry module is an introduction to test coverage metrics. You simply cannot reliably measure test coverage without first having this deterministic, reproducible pipeline in place. We literally had to build the factory and organize the assembly line before we could even think about measuring its efficiency. So, I'll leave you with this question. Are you ready to build your reproducible testing factory? Implement these scripts, set up these directory structures, and just watch your debugging time absolutely plummet. Thanks so much for hanging out with me for this explainer. To master more Ethereum dev stacks and frameworks and really take your engineering skills to the next level, be sure to head over to forge.college. See you in the next one.